When you picture ancient human migration, what comes to mind? You're probably picturing like figures bundled up in heavy furs, clutching spears and trudging through blinding snow across some frozen land bridge.
Right, like Beringia. It's
Yeah.
that very classic, very grounded image of how we populated the Earth.
Exactly. But today we're doing a custom deep dive into something that completely shatters that frozen wanderer narrative. Because 65,000 years ago, on the other side of the world, early humans were doing something entirely different. They were sailing.
Which is wild. I mean, it completely forces us to abandon this lingering idea that early humans were strictly land-bound until, relatively recent history.
Yeah, we are diving into the very first human colonization of Sahul. And for those of you unfamiliar with the term, Sahul was the ancient supercontinent that existed during the Pleistocene.
The epoch we usually just call the Ice Age.
Right. Because global sea levels were so low back then, modern-day Australia, New Guinea, and Tasmania were all tainted as one massive landmass. And our mission today is to synthesize a stack of incredible sources, from archaeological site data and cutting-edge genomic sequencing to, complex geographical computer models.
To really understand how the ancestors of modern Aboriginal Australians pulled off the world's first great maritime migration.
Okay, let's unpack this, because the sources present a staggering geographical problem. Even at the absolute peak of the last ice age, when sea levels were roughly 120 meters lower than today, the ocean was still in the way.
Yeah, it wasn't a straight shot.
No. You had mainland Asia forming a connected landmass called Sunda, and then you had Sahul, but right between them was Wallachia. And you can basically think of Wallachia as this maze of islands separated by incredibly deep oceanic trenches.
And what's fascinating here is that those deep trenches meant the water never froze into a land bridge, and it never drained away.
So they were stuck.
Well, even at the absolute lowest sea levels, to reach Sahul, these early humans still had to cross at least 90 to 100 kilometers of treacherous open ocean.
Which is just a massive distance.
It really is. And this is the crux of the paradigm shift. The first humans to arrive in Australia didn't walk. And achieving a 100-kilometer ocean crossing tens of thousands of years ago, it fundamentally rewrites our entire timeline of human cognitive and technological progress.
But realistically, I have to ask, couldn't this have just been a freak accident? Because for decades, there was this prevailing theory in the scientific community, right? The accidental drift theory.
Right, the idea that a massive tsunami hits an island in Wallachia, a few dozen people cling to some uprooted trees, and they just happen to wash ashore on this massive unknown Australian continent.
Yeah, that's like saying a whole village accidentally drifted to Hawaii on a log. How could an accident result in a thriving continental population?
It was definitely a fallback explanation for a long time, mostly because researchers just couldn't fathom early humans possessing advanced maritime technology. But modern computer drift modeling completely destroys that accidental theory.
How so?
Well, researchers didn't just guess. They built these incredibly complex simulations. They fed paleoclimate data into the model, so ancient ocean currents, historical wind patterns, the exact coastlines of the Pleistocene. And then they ran thousands of virtual drift trajectories from various islands in Wallachia to see where passive, unsteered debris would actually go.
And where does it go? Does it hit Australia?
Mostly it just gets swept out into the Indian Ocean, or it gets trapped in swirling coastal eddies. The models show that the probability of randomly drifting to Sahul by any route is actually less than 5%.
Wow, less than 5%.
Yeah. The math of an accidental colonization only works if you invent this highly unrealistic, catastrophic scenario. You would need something like 40 adults being washed off an island together, surviving the open ocean, and landing safely on Sahul at least once every 20 years consistently for centuries.
Which is statistically absurd. Plus, if you look at the genetic data in our sources, you can't populate an entire continent with 3 exhausted castaways clinging to driftwood.
No, absolutely not.
You need a viable breeding population to avoid immediate genetic bottlenecking and extinction.
Precisely. We use demographic modeling to look at the genetic diversity of modern populations and work backward to calculate the effective founding population. And the genomic data strongly suggests the initial founding population of Sahul was a minimum of 72 to 100 individuals.
Wow.
And the models actually point to a likelihood of up to 400 people arriving in that initial wave, or maybe closely timed waves.
So we aren't talking about a lucky raft. We are talking about a deliberate, highly coordinated migration requiring risk assessment, supply gathering, and serious social organization.
Exactly. It was a purposeful voyage into the unknown by hundreds of people at once.
But if they were organized enough to make a deliberate mass crossing, that brings up an enormous logistical question. Who exactly were these early oceanographers, and how do we even trace them?
Well, our sources point to a major breakthrough that came from a pretty unusual place, a 100-year-old lock of Aboriginal hair.
Which is amazing.
It really is a brilliant example of how historical artifacts and modern science intersect. This lock of hair was collected in the early 20th century in Western Australia. By sequencing its genome and comparing it with modern genomic data from across the region, geneticists were able to build a timeline of migration.
How does that actually work, though? How does a single lock of hair give you a timeline spanning tens of thousands of years?
Right, it's based on the concept of a genetic clock. Think of human DNA like a massive manuscript that gets photocopied every time a new generation is born. Every so often, a tiny typo, a harmless mutation, appears on the copy. Because these typos happen at a relatively predictable, steady rate, geneticists can basically count the number of accumulated typos between two different populations to calculate exactly how much time has passed since they shared a common ancestor.
Oh, that makes sense. So by reading those genetic typos, they proved that the ancestors of modern Aboriginal Australians and Papuans left Africa in a single major dispersal, and they split off from the ancestors of modern Europeans and Asians incredibly early, like roughly 50,000 to 70,000 years ago.
Yes, and as they moved eastward through the Asian landmass and into the island maze of Wallachia, they weren't moving through an empty world.
Right.
Wallachia was a busy meeting ground. As these modern humans hopped from island to island, they encountered and interbred with archaic hominins who were already adapted to the region.
The Denisovans. And for those who aren't familiar, Denisovans were this mysterious, robust group of early humans, kind of like a sister species to Neanderthals, who were highly adapted to extreme environments.
Exactly.
Right.
And the genetic record is clear. Modern Aboriginal Australians and Papuans carry significant traces of Denisovan DNA, alongside about 2.5% Neanderthal DNA.
Wow.
It's like a biological passport, stamped with the populations they met along the way.
Here's where it gets really interesting, though, because despite this intermingling in the islands, the genomic data shows a sudden, dramatic shift once they actually crossed into Sahul. The data indicates that Aboriginal Australians and Papuans possess the most ancient, unbroken ancestry of any group of people outside of Africa.
Yes, because they arrived, and the ocean barrier was so formidable that they essentially became genetically isolated.
You just stayed there.
Right. For tens of thousands of years, they remained distinct, developing their culture without any major back-and-forth migration from the rest of the globe. The sheer isolation of Sahul is what allowed for this uniquely unbroken cultural and genetic continuity.
But looking at a map of Wallachia, staring out at this endless horizon of water, how do they know which way to steer? The sources outline two heavily debated pathways they could have taken through the islands, right? The northern route and the southern route.
Yeah, the geography of the islands basically dictates these two corridors.
So the northern route goes through the island of Sulawesi and into New Guinea. The advantage here is that the island hops are shorter. For a lot of that journey, you have line-of-sight navigation. You can literally see the peak of the next island before you push off the beach of the one you're on.
Which is obviously a huge plus.
Definitely. But then the southern route goes through Bali and Timor, eventually landing in the Kimberley region of northwestern Australia. That route demands much longer, terrifying stretches of open ocean where you are completely out of sight of land. So why would anyone choose the blind southern route if the northern route lets you see where you're going?
Well, if we connect this to the bigger picture, you have to look beyond just the water and look at the land itself. The sources highlight a fascinating ecological strategy here. The islands along the northern route were densely forested, tropical environments, very much like the jungles of modern New Guinea. But the southern route featured open savanna woodlands.
Wait, so the environment matched the Asian savannas they were already hunting in?
Precisely. Early humans expanding out of the Asian mainland were perfectly adapted to savanna hunting and foraging. So they might have actively preferred the dangerous open water crossings of the southern route, simply because the islands along that path offered an ecosystem they already knew how to exploit.
That is brilliant.
Yeah, they were following the familiar savanna, it just happened to be broken up by deep ocean trenches.
And the archaeological evidence seems to lean heavily toward that southern arrival, right? Because we have sites in northwestern Australia, like the Madjedbebe rock shelter, which point to incredibly early human occupation.
Yes. Madjedbebe is a pivotal site. Archaeologists have actually dated human activity there back to an astonishing 65,000 years ago.
But how do you date a rock shelter to 65,000 years? Because carbon dating maxes out around 50,000 years, right? The radioactive carbon isotopes completely decay by then.
That's a great point. To date something that old, researchers use a technique called optically stimulated luminescence, or OSL.
Okay, how does that work?
Instead of measuring decaying carbon in organic material, OSL measures the energy trapped inside grains of quartz or feldspar sand. Basically, when a grain of sand is buried beneath an ancient campfire or a discarded stone tool, it absorbs background radiation from the surrounding earth, trapping electrons over time.
Oh, wow.
Yeah. And when archaeologists shine a specific light on that sand grain in a lab, it releases those trapped electrons as a tiny flash of light. The brightness of that flash tells them exactly how long it has been since that grain of sand last saw sunlight.
That is mind-blowing. So a flash of light from a grain of sand tells us humans were sitting around a fire in northwestern Australia 65,000 years ago. But whether they took the northern jungle route or the southern savanna route, they still had to cross deep, open ocean. They had to navigate using the stars, seasonal wind patterns, bird migrations, which forces the ultimate question skeptics always bring up. If they were navigating open oceans 65,000 years ago, where is the physical evidence of the boats? We don't have a single shipwreck.
Right. And it's the classic archaeological problem of the perishable record. We really have to be realistic about what maritime technology looked like in the Pleistocene.
Yeah.
They weren't forging metal hulls or using fiberglass.
Right.
They were building watercraft out of strictly organic materials. Wood, bamboo, vines, bark, plant fiber. In a highly active tropical marine environment, those materials decompose rapidly. You are not going to find a 65,000-year-old wooden raft.
Plus, the ocean itself hid the evidence.
Exactly. Remember the 120-meter rise in sea level since the end of the Ice Age. The original coastlines where these voyagers first landed, their initial coastal camps, and any discarded watercraft are now buried beneath meters of sediment miles off the current coastline of Australia at the bottom of the ocean.
It makes me think of building a modern space shuttle, but building it entirely out of biodegradable materials like bamboo and hemp.
Oh, I like that.
Right. If that shuttle lands on a new planet and immediately decomposes into the soil over a few decades, future explorers wouldn't find the ship. But the fact that human beings are walking around on that new planet with a viable breeding population is the undeniable proof that the technology existed. The people themselves are the evidence.
That's an excellent analogy, but we aren't totally in the dark about the technology. We actually have strong indirect evidence.
Right. The sources point out that giant bamboo is native to this region of Wallachia, and giant bamboo is incredibly strong, and it's naturally buoyant because of the hollow, airtight nodes inside the thick stalks. If you lash dozens of those massive stalks together with woven plant fibers, you can engineer highly stable, unsinkable rafts capable of carrying dozens of people and heavy supplies over rough seas.
Or, if we look specifically at the southern route, archaeologists have uncovered heavy-duty shell adzes on the island of Timor.
Okay, what's an adze?
An adze is a specialized cutting tool, and these were made from massive, durable marine shells. They're perfectly designed for gouging and hollowing out massive tree trunks. This strongly suggests the manufacturing of deep-hull dugout canoes, which would be essential for cutting through the swirling, violent currents between those southern islands.
So they build these vessels, survive the 100-kilometer crossing, and land on the beaches of Sahul. Did they just pitch a tent on the beach and stare at the ocean for a few millennia?
Far from it. The computer landscape modeling tracks how quickly they moved once they arrived, and the speed is just staggering. The models suggest they populated the entire massive continent in roughly 156 to 208 generations.
Wait, 150 generations to conquer an entire continent? That means they weren't just surviving on the margins. They were fundamentally mastering entirely new biomes almost as fast as they encountered them. They used ancient riverine corridors as superhighways to push inland. They figured out how to thrive in the punishing, arid deserts of the interior and the freezing, temperate zones in the south.
And to do that, they had to innovate. They didn't just adapt to the environment. They engineered tools to manipulate it.
Like the ground edge axes. The sources highlight that Aboriginal Australians invented the world's first ground edge axes. For context, earlier stone tools were usually made by chipping or flaking stone to create a sharp, brittle edge.
Right, which breaks easily.
Exactly. But a ground edge axe is made by aggressively grinding the stone against another abrasive rock until it forms a smooth, incredibly durable wedge. It's a massive technological leap because it allows you to chop dense hardwood timber without your tool constantly shattering.
This rapid adaptation across the continent is incredible. But what I find even more compelling is the deep time memory of this changing landscape.
Oh, yeah.
As these populations spread across Sahul, the Ice Age eventually began to end. The glaciers melted, and global sea levels violently rose, drowning those ancient coastlines.
Erasing the very land bridges and coastal plains they first walked on.
Yes, and the sources reveal something truly extraordinary about how that geological trauma was recorded. Aboriginal oral traditions from specific coastal areas, like places like Port Phillip Bay in the southeast and Fowler's Bay in the south, accurately describe massive ocean deluges.
Wow.
The stories detail the sea aggressively breaking through barriers and permanently flooding what used to be dry kangaroo hunting grounds.
So what does this all mean? When geologists actually map and date the core samples of the sea level rises in those specific bays, the geological record perfectly matches the oral stories.
Exactly.
Those floods occurred between 7,000 and 13,000 years ago. These aren't just colorful allegories or spiritual metaphors. They are empirically accurate, handed-down geological records. We are talking about oral histories that have survived for hundreds of generations.
Which raises an important question about the biases of modern science. Because for a long time, the academic consensus, which was heavily influenced by Western historical methods, was that oral traditions inevitably degrade.
Right.
The assumption was that you can't trust a spoken story after about 800 years. The thought was it becomes this game of generational telephone where facts are embellished into fantasy. But the survival of these sea level rise stories in Australia completely shatters that 800-year ceiling.
It totally does.
It proves that a culture with highly structured laws around storytelling, cross-checking, and knowledge-keeping can preserve pure empirical data for over 10 millennia.
It's just awe-inspiring when you put all the pieces together. The first ancestors of Aboriginal Australians were, without a doubt, the world's first oceanographers. Tens of thousands of years before the Vikings ever conceptualized a longship, thousands of years before the Polynesians navigated the vast Pacific, these early humans engineered deliberate, massive maritime migrations. They looked at a 100-kilometer expanse of ocean, built the technology to cross it, rapidly mastered a completely alien continent, and managed to preserve the memory of their drowning world through an unbroken, rigidly accurate oral tradition that survives today.
It completely reframes our understanding of ancient human capability.
Yeah.
And if we connect this to the bigger picture, it leaves us with a final thought to mull over.
What's that?
If Aboriginal Australian oral traditions perfectly preserve the geological reality of sea level rises from 10,000 years ago, what other ancient Indigenous stories around the world have we dismissed as myths that are actually empirical historical records just waiting for modern science to catch up and validate them?
Wow. That is a question that will absolutely stick with me. Thank you for joining us on this custom deep dive. Keep exploring, keep questioning the history you thought you knew, and remember, sometimes the biggest paradigm shifts happen when we realize that the ancient footprints we were looking for in the snow were actually left on the deck of a boat. See you next time.